Hi everyone, welcome to my third video. In this one I'm going to talk about how you can design 3D printing parts so that they can be printed out in a cleaner way. So what I want to do right now is look at the 3 holes in this duct. This duct will be part of a lift assembly system where I will be using desk rails to design a lift. In this case, I do not want to use bolts that are too thick, so I would like to use an M3 bolt, which is a bolt with a 3mm diameter. But then one single bolt is too weak, so I ended up thinking that I may have to make a gearbox, a pulley box for all the pulleys and the supports to be in. So let me show you a really basic design of what I was thinking. So I'm going to start off with a new part. What I'm hoping is, in this new part, I would be able to have a single pulley and 2 other supports, but then I would be using 3 bolts to put on this pulley box so that it will be sharing the weight altogether. So I'm going to start off by drawing a rectangle. Of that rectangle, I'm going to offset the entities. The other side, make it 2mm thick. Let's make it extruded, I guess 20 mils height to be exactly, say, 35. And now I'm going to extrude it right until here, and then I'm going to make 3 holes like this. I'm going to sketch, convert entities, convert these 3 holes, convert entities, this hole, that hole, and the end this hole. And I'm going to make a hole in this part using these 3. Before that, I will have to trim this in, and then I can cut now. Boom. Now I basically have a gearbox assembly. Let's make this a little longer, 40 mils. And yes, I have a gearbox assembly. In this assembly, I'm going to add in some bolts, some M3 bolts, and symmetric bolts and screws, socket heads, this one, let's do it again. I want this to be an M3 bolt with, okay, that's a very similar length. I'm going to put 3 bolts in here like this. Yes, I added in that thing wrong, so I'll get rid of it, and this one as well. In this case, here I want to have a spacer that kind of saves space. Here I want to put a pulley. So let's start off with a spacer. I'm going to insert a new part in here. I'm going to make a circle. In this case, it'll be 3 mils probably. That was a wrong click. Okay, wrong place. Let's get rid of that part. Let's make another one. No external references. I misclicked that the last time I was playing with parts here. Let's change the mode of the circle, and I have the center right here. Make this 3 mils. 3 mils, I'm going to give that an offset. of 2 mils and then extrude it so that it can serve as a spacer. And I want that to be up here as well, so I'm going to do a copy with mates. Copy that. Now I have that part, let's make them concentric. Make this fit. Alright. 2 mils may be a little too thick. Let's just make that 1 mil. And I'm going to copy that with mates. Concentric, coincident, yes. Copy with mates, concentric, and then coincident, copy, yes. And now I want to design a pulley. Let's make a pulley in a different place. If you want to make a pulley, when you're making a pulley, you're basically just rotating something all around. Like, here's a center line. And then in that, you're basically rotating something like this. Let's mirror and trace across that side. Right, let's gonna. Now we have that. Let's make this length, say 6 mils. This height 3 mils. This one 2 mils. This thickness 2. Right, 1. Shoot 1 and 1 as well. Right, no. I have to find that. I'm going to rotate it. I'm going to make the axis of revolution here, and then we have a very crude looking pulley. Okay, this is very crude looking within SolidWorks. Let's just make the 1.5 so that it looks more like a pulley. Let's just reduce the entire width by itself like this. So for now, let's go with this. We also need a hole in the center, and to do that, what we can do is we can use a different axis of revolution. So let's make the distance between these two around, say, 2 mils. And then we can edit this revolve feature so that the axis of revolution is right here. And now we have a circle as well. Let's save this into a pulley part. And then we can insert that here. So, okay. Yes, we could change the dimensions of the pulley a little, but then let's say this is basically what we want to print out. So if you're going to ever print something out, we're going to print out this gearbox, these spacers, and this pulley. So first I'm going to try showing you what might happen if you try to print out this pulley. So in order to print something, you have to first save it into an STL format, and then use whatever printing software that comes with your printer. For example, with the Robox that I'm using, I have to use a program called an Automaker. Gives that time to load. And then if you're trying to print out something like that pulley, a problem might be So first, you try to print it like this. You're going to need a lot of supports, especially for this circle, for the center of the circle, and also the edges. And also, if you lay it flat again, you're going to again need supports to keep the flanges of the top open. And usually, if you use supports, the parts usually end up not looking that good. It takes longer. It takes a longer time to print. It's less durable. You use more filament. So usually it's better to find a way of printing something like this without having to use supports. Something even worse would be this. If we are going to try to print this gearbox out, yes, it's not really necessary for the holes to be the right size because we can drill them after we're done printing, but then we need them to be at the right position. If we end up printing this part like this, yes, the rectangle is going to come out right, but then the circle is going to get screwed up. If we print it out this way, yes, maybe the circles will come out right, but then this top layer may be unstable when you're printing it out. So what you'll have to end up doing is you'll have to split these 3D printable parts up. So instead of making something like this, you have to make a different part. You'll have to make a part that is half of a pulley and then put two of them together to make a whole pulley. By that I mean something like this. So it's going to be really similar to the one that we just saw, but then it's going to be a little different. Because this pulley is going to have only one flange. Like this. Center distance would be 2. That would be 1. Remember it was 3, so 2, 1. They may end up looking a little different, but then the goal of this is to show how that can be changed so that it prints out better. Let's save that as pulley divided. And then in the assembly, what will end up happening is instead of putting a whole pulley, we'll have to have 2 of these. One like that, the other like this. We're going to add these 2 up to make a whole pulley. And let's see what will happen if we try to print this one out. Print the divided pulley out. If we save it as a, let's go save it as an STL format once again. All bodies. Let's add this. I have to lay that flat, but also we'll have to duplicate it. And we will need to duplicate it 4 times if you want to make 2 pulleys, but then you can very easily see that this is going to be a very, very clean print job. It's not going to require any support, it's going to be literally very clean. And all you need to do is print it out and then put them up and put it together so that you'll end up having so that these parts will come out in a very clean fashion. And what we can do for this rectangle is we can divide it up into 2 pieces by dividing this part and that part. What I mean is we can do something like this. And then extrude that for, say, 20 mils. And then here, put the 3 circles that we put in before. And then let's give that a center line. Linear sketch pattern. 1, 2, 3. We're going to make that tall, 3 mils large. Make this distance also, right, no. And then also make the distance between this and this into 10 mils. And we can cut. Let's change the sketch so that this is 40 mils long. And then we have this part. Box divided. And in here, let's put in the box divided part. Copy it. And then assemble them once again. Like this. And then we have a gearbox that we can print out in a very clean manner. If you want to see how we would print this part out, we would be doing something like this. Let's get rid of these. We would be printing that out like this. And if you print it out like this, it's going to be a very clean job as well. And that's the end of this tutorial. What you have seen in this tutorial is basically the fact that sometimes you have to divide parts up into 2 or 3 different pieces so that they can be printed in a cleaner manner when you're printing it using a 3D printer. And in the next video, I will talk about how to make this pulley box a little better. It is better to have these pulleys surrounded by bearings, and in order to choose which bearings you want to use, it's usually really good to use the CAD data that's provided by the companies that sell those parts. So thank you.